Giant wind turbines used to generate electricity could soon be replaced with tiny, leafless mechanical trees. Researchers are testing objects that mimic trees to see if they have the potential to generate power when rustled by the wind. The team has demonstrated that tree-like structures made with electromechanical materials can turn wind into vibrations that are ideal for generating electricity. The technology may prove most valuable when applied on a small scale, in situation where other renewable energy sources such as solar are not an option, said project leader Ryan Harn. The trees, made of steel, feature a trunk with a few branches sprouting from it. Researchers see this technology starting off in civil infrastructures, such as buildings and bridges. Harn envisions tiny trees sending power to a sensor underneath a bridge or on a girder inside a high-rise building. The project takes advantage of the vibrational energy that surrounds us every day, such as from the noise on city streets, he said. Buildings sway ever so slightly in the wind, bridges oscillate when we drive on them, and car suspensions absorb bumps in the road, said Harn. In fact, there's a massive amount of kinetic energy associated with those motions that is otherwise lost. We want to recover and recycle some of that energy. The initial goal is to turn the vibrations into electricity, and sensors will be used to monitor the soundness of a structure by detecting these vibrations. If the sensors are able to capture these vibrations, the data could be transmitted into energy, reducing the cost and maintenance of batteries. Harn and his team designed a mathematical model, which was a small tree-like device constructed out of steel beams that were connected through a strip of electromechanical material, polyvinylidene fluoride, PVDF, to convert the structural swing into electrical energy. The model tree was attached to a device that shook it back and forth at high frequencies. The frequency was so high that the movement was invisible to the human eye, but it produced about 0.8 volts from the motion. In addition, we introduced massive amounts of noise, and found that the saturation phenomenon is very robust, and the voltage output reliable. That wasn't known before, Harn said.